If I can add something, the general principle here is that any part of this could fail and the car will keep driving. So you could have cameras fail, you could have power circuits fail, you could have one of the Tesla full self-driving computer chips fail, car keeps driving. The probability of this computer failing is substantially lower than somebody losing consciousness. That's the key metric, at least an order of magnitude. At first, it seems improbable. How could it be that Tesla, who has never designed a chip before, would design the best chip in the world? But that is objectively what has occurred. Not best by a small margin, best by a huge margin. It's in the cars right now. All Teslas being produced right now have this computer. We switched over from the NVIDIA solution for S and X about a month ago, and we switched over Model 3 about 10 days ago. All cars being produced have all the hardware necessary, compute and otherwise, for full self-driving. I'll say that again. All Tesla cars being produced right now have everything necessary for full self-driving. All you need to do is improve the software. And later today, you will drive the cars with the development version of the improved software, and you will see for yourselves. We finished this design like maybe 1.5, 2 years ago, and began design of the next generation. We're not talking about the next generation today, but we're about halfway through it. All the things that are obvious for a next generation chip we're doing. The strategy here, and this started basically a little over 3 years ago, was design and build a computer that is fully optimized and aiming for full self-driving software that is designed to work specifically on that computer and get the most out of that computer. So you have tailored hardware that is a master of one trade, self-driving. NVIDIA is a great company, but they have many customers. And so as they apply their resources, they need to generalize solution. We care about one thing, self-driving. So that it was designed to do that incredibly. The software is also designed to run on that hardware incredibly well. And the combination of the software and the hardware, I think, is unbeatable. What we're going to explain to you today is that LiDAR is a fool's errand. And anyone relying on LiDAR is doomed. Doomed. Expensive sensors that are unnecessary. It's like having a whole bunch of expensive appendices. Like one appendix is bad, now they want to put a whole bunch of them. That's ridiculous. You'll see. If you're driving for an hour in a city and you had a solution hypothetically that was a kilowatt, you'd lose 4 miles in Model 3. So if you're only going, say, 12 miles an hour, then that would be a 25% impact on range in city. Basically, the power of the system has a massive impact on city range, which is where we think most of the robotaxi market will be. So the power is extremely important. We don't want to talk too much about the next generation chip, but it'll be at least, let's say, 3 times better than the current system. I think if somebody started today and they were really good, they might have something like what we have right now in 3 years, but in 2 years, we'll have something 3 times better. The thing that's, I think, a very powerful sustainable advantage for us is the fleet. Nobody has the fleet. Those weights are constantly being updated and improved based on billions of miles driven. Tesla has 100 times more cars with the full self-driving hardware than everyone else combined. By the end of this quarter, we'll have 500,000 cars with the full 8-camera setup, 12 ultrasonics. Some of them will still be on hardware too, but we'll still have the data gathering ability. And then by a year from now, we'll have over 1 million cars with full self-driving computer, hardware, everything. It's just a massive data advantage. It's similar to how the Google search engine has a massive advantage because people use it, and people are effectively program Google with their queries and the results. The simulator, we have quite a good simulation too, but it just does not capture the long tail of weird things that happen in the real world. If the simulation fully captured the real world, that would be proof that we're living in a simulation, I think. Yeah, it doesn't. I wish. But simulations do not capture the real world. The real world's really weird and messy. You need the cars on the road. Simulation, you're fundamentally grading your own homework. If you know that you're going to simulate it, okay, you can definitely solve for it. But as Andre is saying, you don't know what you don't know. The world is very weird and has millions of corner cases. And if somebody can produce a self-driving simulation that accurately matches reality, that in itself would be a monumental achievement of human capability. They can't. There's no way. Everyone's training the network all the time is what it amounts to. Whether autopilot is on or off, the network is being trained. Every mile that's driven for the car that's hardware 2 or above is training the network. The crazy thing is the network is predicting paths it can't even see with incredibly high accuracy. It can't see around the corner, but it's saying the probability of that curve is extremely high. So that's the path, and it nails it. You will see that in the cars today. We're going to turn on augmented vision so you can see the lane lines and the path predictions of the cars overlaid on the video. The car is an inference optimized computer. We do have a major program at Tesla, which we don't have enough time to talk about today, called Dojo. That's a super powerful training computer. The goal of Dojo will be to be able to take in vast amounts of data and train at a video level and do unsupervised massive training of vast amounts of video with the Dojo program, Dojo computer. That's for another day. We're just being like more conservative right now. And then as we gain higher and higher confidence, we'll allow users to select a more aggressive mode. That'll be up to the user. But in the more aggressive modes, in trying to merge in traffic, there is a slight, no matter how many there's a slight chance of a fender bender. Not a serious accident, but you basically will have a choice of, do you want to have a non-zero chance of a fender bender on freeway traffic, which is unfortunately the only way to navigate LA traffic. The car can operate if it's completely disconnected from the fleet. It uploads the training that's better and better as the fleet gets better and better. So simply, if you disconnected it from the fleet, from that point onwards, it would stop getting better, but it would still function fine. The compute power in the full self-driving computer is incredible. And maybe we should mention that if it had never seen that road before, it would still have made those predictions, provided it was a road in the United States. They're all going to dump LiDAR. That's my prediction. Mark my words. I should point out that I don't actually super hate LiDAR as much as they sound, but at SpaceX, SpaceX Dragon uses LiDAR to navigate to the space station and dock. Not only that, SpaceX developed its own LiDAR from scratch to do that, and I spearheaded that effort personally. Because in that scenario, LiDAR makes sense. And in cars, it's freaking stupid. It's expensive and unnecessary, and as Andre was saying, once you solve vision, it's worthless. So you have expensive hardware that's worthless on the car. We do have a forward radar, which is low cost and is helpful, especially for occlusion situations. So if there's like fog or dust or snow, the radar can see through that. If you're going to use active photon generation, don't use visible wavelength, because with passive optical, you've taken care of all visible wave stuff. You want to use a wavelength that is occlusion penetrating, like radar. So LiDAR is just active photon generation in the visual spectrum. If you're going to do active photon generation, do it outside the visual spectrum in the radar spectrum. So like at 3.8 millimeters versus 400 to 100 nanometers, you're going to have much better occlusion penetration, and that's why we have a forward radar. And then we also have 12 ultrasonics for near field information, in addition to the 8 cameras and the forward radar. You only need the radar in the forward direction because that's the only direction you're going real fast. So we've gone over this multiple times. Are we sure we have the right sensor suite? Should we add anything more? No. We have 425,000 cars with hardware 2 and beyond, which means they've got all 8 cameras, the radar and the ultrasonics, and they've got at least a video computer, which is enough to essentially figure out what information is important, what is not, compress the information that is important to the most salient elements, and upload it to the network for training. So it's a massive compression of real-world data. I suppose it could possibly be used for something besides self-driving. We've been super focused on self-driving, so as we get that really nailed, maybe there's going to be some other use for millions and then tens of millions of computers with hardware 3 or full self-driving computer. Yeah, maybe there would be. It could be, maybe there's some sort of A angle here. It's possible. There are a number of important signals, as Andre was saying. Lane lines are one of those things, but one of the most important signals is drive space. So what is drivable space and what is not drivable space? And what actually really matters the most is drivable space more than lane lines. And the prediction of drivable space is extremely good. And I think, especially after this upcoming winter, will be incredible. It will be like, how could it possibly be that good? That's crazy. It's extremely important that things not be rigidly tied to GPS, because GPS error can vary quite a bit. And the actual situation for a road can vary quite a bit. So there could be construction, there could be a detour, and if the car is using GPS as primary, this is a real bad situation. It's asking for trouble. It's fine to use GPS for like tips and tricks. So you can drive your home neighborhood better than a neighborhood in some other country or some other part of the country. So you know your own neighborhood well, and you use like the knowledge of your neighborhood to drive with more confidence, to maybe have counterintuitive shortcuts and that kind of thing. But the GPS overlay data should only be helpful, but never primary. If it's ever primary, it's a problem. High precision GPS maps and lanes are a really bad idea. The system becomes extremely brittle. So any change, like any change to the system makes it can't adapt. So if it locks onto GPS and high precision lane lines and does not allow vision override. In fact, vision should be the thing that does everything, and then like lane lines are a guideline, but they're not the main thing. We briefly balked up the tree of high precision lane lines and then realized that was a huge mistake and reversed it out. It's not good. There's 3 steps to self-driving. There's being feature complete. Then there's being feature complete to the degree that where we think that the person in the car does not need to pay attention. And then there's being at a reliability level where we've also convinced regulators that is true. So there's 3 levels. We expect to be feature complete in self-driving this year, and we expect to be confident enough from our standpoint to say that we think people do not need to touch the wheel, look out of the window, sometime probably around, second quarter of next year. And then we start to expect to get regulatory approval, at least in some jurisdictions, for that towards the end of next year. That's roughly the timeline that I expect things to go on. And probably for trucks, the tuning will be approved by regulators before anything else. And you could have maybe, if you're doing long haul freight, you could have 1 driver in the front and then have 4 semis trailing behind in a platooning manner. And I think that probably the regulators will be quicker to approve that than other things. In order to have a self-driving car or robotaxi, you really need redundancy throughout the vehicle at the hardware level. Starting in, I believe it was October 2016, all cars made by Tesla have redundant power steering. So we have redundant motors on the power steering. So any one failure if the motor fails, the car can still steer. All of the power and data lines have redundancy. So you can sever any given power line or any data line and the car will keep driving. The auxiliary power system, even if the main pack, you lose complete power in the main pack, the car is capable of steering and braking using the auxiliary power system. So you can completely lose the main pack and the car is safe. The whole system, from a hardware standpoint, has been designed to be a robotaxi since basically October 2016. So when we rolled out hardware, Autopilot version 2. But we do not expect to upgrade cars made before that. We think it would actually cost more to make a new car than to upgrade the cars. Just to give you a sense of how hard it is to do this. Unless it's designed in, it's not worth it. So we've gone through the future of self-driving, where it's hardware, it's vision, and then there's a lot of software. And there's the software problem here should not be minimized. It's a massive software problem that, managing vast amounts of data, training against the data, how do you control the car based on the vision? It's a very difficult software problem. So going over just like Tesla master plan, obviously we've made a bunch of forward-looking statements, as they call it. But let's go through some of our other forward-looking statements that we've made. Way back when we created the company, we said we'd build the Tesla Roadster. They said it was impossible, and that even if we did build it, nobody would buy it. It was like universal opinion was that building an electric car was extremely dumb and would fail. I agreed with them that the probability of failure was high, but that this was important. So we built the Tesla Roadster, got it into production in 2008, and shipping that car. It's now a collector's item. Then we built a more affordable car with the Model S. We did that. Again, we were told that's impossible. I was called a fraud and a liar, and it was not going to happen. This is all untrue. Okay, famous last words. Now we went into production with the Model S in 2012. It exceeded all expectations. There is still, in 2019, no car that can compete with the Model S of 2012. It's 7 years later. We're waiting. So we'd build an affordable car, maybe highly affordable. It's affordable, more affordable with the Model 3. We built the Model 3. We're in production. Said we'd get over 5,000 cars a week for Model 3. At this point, 5,000 cars a week is a walk in the park for us. It's not even hard. So we'd do large-scale solar, which we did through the SolarCity acquisition, and that we'd develop and deploy the solar roof, which is going really well. We're now on version 3 of the solar tile roof, and we expect to spool up production of the solar tile roof significantly later this year. I have it on my house, and it's great. And I make the power wall and the power pack, and we made the power wall and power pack. In fact, the power pack is now deployed in massive grid-scale utility systems around the world, including the largest operating battery projects in the world that at above 100 megawatts. And in the next 2 years at the most, we expect to have a gigawatt scale battery project completed. So all these things, I said we would do them, we did it. Said we'd do it, we did it. We're going to do the robotaxi thing too. Only criticism, and it's a fair one, and sometimes I'm not on time, but I get it done, and the Tesla team gets it done. So what we're going to do this year is we're going to reach combined production of 10,000 a week between SX and 3. Feel very confident about that. And we feel very confident about being feature complete with self-driving. Next year, we'll expand the product line with Model Y and Semi, and we expect to have the first operating robo-taxis next year with no one in them next year. It's always difficult to, like when things are on an exponential at an exponential rate of improvement, it's very difficult to wrap one's mind around it because we're used to extrapolating on a linear basis. But when you've got massive amounts of hardware on the road, the cumulative data is increasing exponentially. Software is getting better at an exponential rate. I feel very confident predicting autonomous robo-taxis for Tesla next year. Not in all jurisdictions because we won't have regulatory approval everywhere, but I'm confident we will have at least regulatory approval somewhere literally next year. So any customer will be able to add or remove their car to the Tesla network. So we expect this to operate as like a combination of maybe the Uber and Airbnb model. So if you own the car, you can add or subtract it to the Tesla network, and Tesla would take 25 or 30% of the revenue. And then in places where there aren't enough people sharing their cars, we would just have dedicated Tesla vehicles. So when you use the car, we'll show you our ride-sharing app. So you'll be able to summon the car from the parking lot, get in, and go for a drive. It's really simple. So you just take the same Tesla app that you currently have, we'll update the app and add a summon Tesla or commit your car to the fleet. So it's either summon your car or summon a Tesla or add or subtract your car to the fleet. You'll be able to do that from your phone. So we see potential for smoothing out the demand distribution curve and having the car operate at a much higher utility than a normal car would operate. So like typically the use of a car is about 10 to 12 hours a week. So most people will drive 1.5 to 2 hours a day, typically 10 to 12 hours a week of total driving. But if you have a car that can operate autonomously, then most likely you'd have that car operate for a third of the week or longer. So there are 100 hours in a week. So probably you've got something on the order of 55 to 60 hours a week of operation, maybe a bit longer. So the fundamental utility of the vehicle increases by a factor of 5. So you can look at this from a macroeconomic standpoint and say just, if this was like if we were operating some big simulation, if you could upgrade your simulation to increase the utility of cars by a factor of 5, that would be a massive increase in the economic efficiency of the simulation. Just gigantic. We'll do Model 3, S3 and X as taxis, but we made an important change to our leases. So if you lease a Model 3, you don't have the option of buying it at the end of the lease. We want them back. If you buy the car, you can keep it, but if you lease it, you have to give it back. And as I said, where in any locations where there's not enough supply for sharing, Tesla will just make its own cars and add them to the network in that place. So the current cost of a Model 3 robo-taxi is less than $38,000. We expect that number to improve over time, and we're designing the cars. The cars currently being built are all designed for 1 million miles of operation. So the drive units are designed and tested and validated for 1 million miles of operation. The current battery pack is about maybe 300 to 500,000 miles. The new battery pack that's probably going into production next year is designed explicitly for 1 million miles of operation. The entire vehicle is designed to operate for 1 million miles with minimum maintenance. So we'll actually be adjusting tire design and really optimizing the car for a hyper-efficient robo-taxi. And at some point, you won't need steering wheels or pedals, and we'll just delete those. So as these things become less and less important, we'll just delete parts. They won't be there. If you say like probably 2 years from now, we make a car that has no steering wheels or pedals. And if we need to accelerate that time, we can always just delete parts, easy. Probably say long-term, 3 years, robo-taxis with eliminated parts, maybe it ends up being $25,000 or less. And we want a super efficient car so that the electricity consumption is very low. So we're currently at 4.5 miles per kilowatt hour, but we'll improve that to 5 and beyond. And there's just really no company that has the full stack integration. We've got the vehicle design and manufacturing, we've got the computer hardware in-house, we've got the in-house software development and AI, and we've got by far the biggest fleet. It's extremely difficult, not impossible perhaps, but extremely difficult to catch up when Tesla has 100 times more miles per day than everyone else combined. These today is the cost of running a gasoline car, or the average cost of running a car in the US. This is taken from AAA. So it's currently about 62 cents a mile, 1,500 miles, 250 million vehicles, adds up to $2 trillion a year. These are literally just taken from the AAA website. Cost of ride sharing is, according to Uber and Lyft, is $2 to $3 a mile. The cost to run a robo-taxi, we think less than 18 cents a mile and dropping. Like this would be current. This current cost. Future cost will be lower. You say, what would be the probable gross profit from a single robo-taxi? We think probably something on the order of $30,000 per year, and we expect that we're literally designing. We're designing the cars the same way that commercial semi-trucks are designed. Commercial semi-trucks are all designed for a million-mile life, and we're designing the cars for a million-mile life as well. So in nominal dollars, that would be a little over $300,000 over the course of 11 years. It might be higher. I think these consumptions are actually relatively conservative, and this assumes that 50% of the miles driven there's nothing or not useful. So this is only at 50% utility. By the middle of next year, we'll have over 1 million Tesla cars on the road with full self-driving hardware, feature complete at a reliability level that we would consider that no one needs to pay attention. Meaning you could go to sleep from our standpoint, if you fast forward a year, maybe a year and 3 months, but next year for sure, we will have over 1 million robo-taxis on the road. The fleet wakes up with an over-the-air update. That's all it takes. You say, what is the net present value of a robo-taxi? Probably on the order of a couple $100,000. So buying a Model 3 is a good deal. Questions? Our production rates generally, if you look at our compound annual production rate since 2012, which is that's our first full year of Model S production, we went from 23,000 vehicles produced in 2013 to around 250,000 vehicles produced last year. So in the course of 5 years, we increased output by a factor of 10. I would expect that something similar occurs over the next 5 or 6 years. As for sharing versus, I don't know. The nice thing is that essentially customers are fronting us the money for the car. It's great. Sure, we expect the solving for the snake charger is pretty straightforward. It's from a vision problem standpoint. It's like a known situation. Any kind of known situation with vision is like a charge port. It's trivial. Yeah, the cars would just automatically park and automatically plug in. There would be no human supervision required. Yeah. Sorry, the other part was pricing. We just threw some numbers on there. I think it's definitely plug in whatever pricing you think makes sense. We just randomly said, okay, maybe $1. And the thing is, there's on the order of 2 billion cars and trucks in the world. So robotaxis will be in extremely high demand for a very long time. And from my observation thus far is that the auto industry is very slow to adapt. Like I said, there's still not a car on the road that you can buy today that is as good as the Model S was in 2012. So that suggests a pretty slow rate of adaptation for the car industry. And so probably $1 is conservative for the next 10 years. Because people think, there's actually not enough appreciation for the difficulty of manufacturing is insanely difficult. But a lot of people I talk to think if you just have the right design, you can instantly make as much of that thing as the world wants. This is not true. It's extremely hard to design a new manufacturing system for new technology. Audi's having major problems manufacturing e-tron, and they're extremely good at manufacturing. And if they're having problems, what about others? So there's on the order of 2 billion cars and trucks in the world, on the order of about 100 million units per year of production capacity of vehicles, but only of the old design. It will take a very long time to convert all of that to full self-driving cars. And they really need to be electric because the cost of operation of a gasoline diesel car is much higher than an electric car. So any robotaxi that isn't electric will absolutely not be competitive. There's a clause that we put into our cars, I think it was about 3 or 4 years ago. They can only be used in the Tesla network. Yes, but it's like the App Store. You can only add or remove them through the Tesla network, and then Tesla gets revenue share. I guess you could operate a rental car fleet, but I think this is very unwieldy. I think there will be a phone home thing where if the car gets stuck, it'll just phone home to Tesla and ask for a solution. Things like being pulled over by a police officer, that's easy for us to program in. That's not a problem. But it will be possible for somebody to take over using the steering wheel, or at least for some period of time, and then probably down the road, we'll just cap the steering wheel so that there's no steering control. We'll just take the steering wheel off and put a cap on. Yeah, we'll literally just unbolt the steering wheel and put a cap on where the steering wheel handle currently is. I think there'll be a transition period where people will be able to take over and should be able to take over from the robotaxi. And then once regulators are comfortable with us not having a steering wheel, we'll just delete that. And for cars that are in the fleet, obviously with the permission of the owner, if it's owned by somebody else, we would just take the steering wheel off and put a cap where the steering wheel currently attaches. In future, the probability of the steering wheel being taken away in the future is 100%. Consumers will demand it. This is not me prescribing a point of view about the world. This is me predicting what consumers will demand. Consumers will demand in the future that people are not allowed to drive these 2-ton death machines. There were amphibians, but then pretty much things just become like land creatures. There'll be a little bit of an amphibian phase. I think it are a mistake. We actually had HT maps for a while. I actually canned that. Because you either need HT maps, in which case, if anything changes about the environment, the car will break down, or you don't need HT maps, in which case, why are you wasting your time doing HT maps? The HT maps thing, the two main crutches that should not be used and will be obviously false and foolish are LiDAR and AMAPs. If you need a geofenced area, you don't have real self-driving. I think we're actually going to want to push our sort of standard range plus battery more than our long range battery, because the energy content in the long range pack is 50% higher kilowatt hours. So essentially you can make a third more cars if they're all sort of standard range plus instead of the long range pack. So one's like around 50 kilowatt hours, the other one's around 75 kilowatt hours. So we're actually probably going to bias our sales intentionally towards the smaller battery pack in order to have a higher volume of what basically you want to, the obvious thing is to maximize the number of autonomous units or the number of maximize the output that will subsequently result in the biggest autonomous fleet down the road. So we're doing a number of things in that regard, but it's just not for today's meeting. The million mile life is basically just about getting the cycle life of the pack to, you need basically on the order, let's say you've got a basic math, if you've got a 250 mile range pack, you're going to need 4,000 cycles. So very achievable. We already do that with our stationary storage, some of our stationary storage solutions like PowerPack. We're ready to deploy PowerPack with 4,000 cycle life capability. Really fundamental message that consumers should be taking today is that it's financially insane to buy anything other than a Tesla. They will be like owning a horse in 3 years. Fine if you want to own a horse, but you should go into it with that expectation. If you buy a car that does not have the hardware necessary for full self-driving, it is like buying a horse. And the only car that has the hardware necessary for full self-driving is a Tesla. People should really think about their approaches any other vehicle. It's basically crazy to buy any other car than a Tesla. Yeah. We need to convey that argument clearly, and we will have to today. Yeah, we talk to regulators around the world all the time. As we introduce additional features like navigate on autopilot, this requires like regulatory approval on a per jurisdiction basis. I think fundamentally regulators, in my experience, are convinced by data. So if you have a massive amount of data that shows that autonomy is safe, they listen to it. They may take time to digest the information. Their process may take a bit of time, but they have always come to the right conclusion from what I've seen. I think like Tesla-owned robo-taxis would be in dense urban areas along with customer vehicles. And then as you get to medium and low density areas, it would tend to be more that people own the car and occasionally lend it out. Yeah, there are a lot of edge cases in Manhattan and say downtown San Francisco. But there are various cities around the world that have challenging urban environments. But we do not expect this to be a significant issue. When I say future complete, it'll work in downtown San Francisco and downtown Manhattan this year. Right now, AI or neural nets are used really for object recognition. And we're still basically just using it as still frames, so identifying objects in still frames and tying it together in a perception path planning layer thereafter. But what's happening is that the neural net is eating into the software base more and more. And so over time, we expect the neural net to do more and more. Now from a computational cost standpoint, there are some things that are very simple for a heuristic and very difficult for a neural net. And so it probably makes sense to maintain some level of heuristics in the system because they're just computationally 1,000 times easier than a neural net. A neural net is like a cruise missile. And if you're trying to swat a fly, just use a fly swatter, not a cruise missile. So, but over time, I would expect that it moves really to just training it against video, and then video in, car steering, and pedals out. Or basically, video in, lateral and longitudinal acceleration out, almost entirely. That's what we're going to use the Dojo system for. There's no system that can currently do that. Essentially, the car is going to do what a human would do. You can think of a human as like basically a camera on a slow gimbal. And it's remarkable that people are able to drive the car in the way that they are. Because if you can't look in all directions at once. The car can literally look in all directions at once with multiple cameras. So humans are able to drive just by looking this way or looking that way. They're actually stuck in their driver's seat. They can't really get out of the driver's seat. So it's like kind of one camera on a gimbal and is able to drive, a conscientious driver can drive with very high safety. The cameras in the cars have a better vantage point than the person. So they're like up in the B pillar or in front of the rearview mirror. They've really got a great vantage point. So if you're turning onto a road that's got a lot of high-speed traffic, you can just do what a person does, just like turn a little bit, don't go fully into the road, let the camera see what's going on, and if things look good, and then the rear cameras don't show any oncoming traffic, off you go. And if it looks sketchy, you can just pull back a little bit, just like a person. The behavior is like it starts to become remarkably lifelike. It's like quite eerie, actually. The car just starts behaving like a person. Well, we publish the accidents per mile every quarter, and what we see right now is that Autopilot is about twice as safe as a normal driver on average. And we expect that to increase quite a bit over time. Like I said, in the future, it will be consumers will want to outlaw, saying they will succeed, nor am I saying I agree with this position, but in the future, consumers will want to outlaw people driving their own cars because it is unsafe. And if you think of like elevators used to be operated on a big lever, go up and down the floor, and there's like a big relay, and you had elevator operators, but then periodically they would get tired or drunk or something, and then they'd turn the lever at the wrong time and sever somebody in half. So now you do not have elevator operators, and it would be quite alarming if you went into an elevator that had a big lever that could just move between floors arbitrarily. So there's just buttons. And in the long term, again, not a value judgment, I'm saying I want the world to be this way. I'm saying consumers will most likely demand that people are not allowed to drive cars.
And Elon, a follow-up. Can you share with us how much Tesla is spending on autopilot or autonomous technology by order of magnitude on an annual basis? Thank you.
It's basically our entire expense structure. Between now and when the robotaxis are fully deployed throughout the world, the sensible thing for us is to maximize rate and drive the company to cash flow neutral. Once the robotaxi fleet is active, I would expect to be extremely cash flow positive.
Who is liable for an accident? Is it Tesla or is it me if the vehicle has an accident and harms?
Probably Tesla. Yeah, it's probably Tesla. Yeah. I think the right thing to do is just make sure there are very few accidents.